To UTA Planetarium's another live star stream. My name is Levent Gurdemir and I'm here with you today to talk about telescopes. A lot of people ask me how to buy or how to decide the first telescope. So I decided to give some little information about buying a telescope and then how to choose them and what the differences are between the telescopes, because you will see there are a variety of telescopes available. But first of all, and most important thing is, actually all of us or most of us already are equipped with telescope, and that is actually the human eye. So let's take a look at the human eye. So this represents the human eye, and human eye has a lens just sitting right over here, and that lens is about 8 millimeter wide, and the purpose of the lens is it is focusing the incoming light towards the retina, and when a lens focuses a light, then the image actually falls on the background, in this case the retina. And the retina takes the image and converts into electrical signals, and these electrical signals are transmitted to the brain, and the brain sees the object. So this is how it works. And this lens, the 8 millimeter lens over here, is working until some certain range. So we cannot see the objects great if they are close to us, but if the objects are farther and farther away, that 8 millimeter is not enough alone. So in this case, what do? We put a bigger lens right in front of that the natural lens, and the problem is solved. And for distant objects, if you would like to look at the moon, the planets of the solar system, and even the galaxies of the universe, you need a bigger lens than what we have in our eyes. So I wanted to categorize the telescopes into, I just divided into some budget categories, and those are, for example, for if you would like to look at the solar system, the moon, Jupiter, Saturn, Mercury, and Venus, then the budget starts from 100. You can find telescopes on the internet that are $99, and they go up, of course, if you are looking for something better. And the deep sky objects, such as nebulae, galaxies, and clusters, they can be more expensive to look at. So the budget usually starts from, for a good telescope, from $700, $800 range. And finally, we'll talk about a little bit astrophotography telescopes. Those are high budget because you need to buy expensive parts. The telescope is not alone enough for the astrophotography. You need to buy some additional converter pieces and the telescope mount, etc. And the starting budget I set is for $1,200, and believe me, this is really the starting point, and it goes and actually skyrockets significantly as you go into more professional. Of course, we are not going to talk about the professional telescopes. Those are extremely high budgets, can cost hundreds of thousands of dollars. We can maybe cover that in a different stream. And especially, we are not going to talk about space telescopes like this. This is the mock-up of Hubble Space Telescope. This is pretty expensive, and you certainly don't need that for backyard astronomy. All right. In the next chapter, we are going to look at different types of telescopes. So those are pretty much basically reflectors, refractors, Dobsonians, and Cassegrains. Reflecting telescopes are using lenses. We made a mistake actually in here in the slide. It must be refractors, not reflectors. So please forgive that mistake. So we are not looking at reflectors in the top left corner on the screen. This is refractors. Those are using lenses. It's great for solar system, and they are pretty easy to point telescopes. And refractors, they are using mirrors. Sorry, reflectors are using mirrors. So mirror actually reflects the light. It's coming from the name of or the purpose of the mirror. They are great for solar system. They are going to be okay for deep sky objects, but the small sizes are not going to be sufficiently showing the details, and they are not easy to point. We are going to talk about that too. Dobsonians is another type of reflecting telescope. The tube, the principle is the same. The difference is the mount. And when you look at the mount, it is actually sitting on the ground, and there is just a fork handle. So it is very inexpensive to make or very inexpensive to buy comparing to similar categories. But their problem is they are little bulky and difficult to point. So they really require some expertise to point an object and enjoy the images. Cassegrains are the last and the most common type for expensive telescopes. They are using both combination of lenses and mirrors, and most come with the motorized systems and computer controls. So you can, once you set up your telescope, you can actually select the object on the computer, and the telescope finds the object for you, centers it for you. It's very easy, but the setting up is a little bit tricky. So when we are talking about telescopes, we compare the telescopes with their sizes. So the first specification we express about telescope is the size of telescope, and the size of the telescope is measured by its diameter. It will be either in centimeters or inches. In this case, in the telescope in the picture is 4 inches telescope. So that's important because that's the light collecting power of the telescope. The larger telescope is the better telescope. That's always true. So let's take a look at different types of telescopes. So let's visit refractors first. So refractors, as we mentioned, they are using the lens system, and the lens are well, it is one of the cheapest way to make telescope if you are using small lenses. So, for example, Galileo used this type of telescope to discover Jupiter's moons. So it is basically one or two set of lens that focuses the light, and we see the object. So for small telescopes, it is great. For bigger telescopes, when we need bigger refractors, the big lenses are extremely expensive to make and extremely difficult. So we only use larger refractors at the big old observatories. So if you would like to buy a larger refractor, it is either not available or extremely expensive. You will find this out when you are shopping for telescopes. So because making a big lens is expensive, and people need bigger telescopes to discover other things in the sky. Another option is, and first Newton actually came with this idea, that, by the way, hi Braxton, good to see you here again. And we are very that sells telescope in Dallas area. Unfortunately, there was a great telescope shop that I liked in Dallas, but they closed their business long time ago because the telescope selling is not very profitable business. The equipment is expensive, the accessories are expensive, and they didn't make enough sales to support their shop, so they closed it. And a lot of shops I know in the United States closed down the stores for the similar reason. Well, you may be looking at some of the museums and planetariums gift shops. We also had some telescopes and accessories at our gift shop, and the online websites are pretty good source for telescopes, so you are pretty much you have a best bet online. The downside of online shopping is you don't have any experts who can help you. So I'm hoping this video will help a little to start with. And some of the museums and planetariums will have some experienced people to help people about buying telescopes too. Great questions. Please drop your questions to the comment chat, so I can get that answered. So let's continue with reflectors. Reflectors are using mirrors, as we said. So they are first focusing the image towards a secondary mirror, and the secondary mirror diverts the light to an eyepiece. So in this case, you are looking at the diagram over here, and I have an example to reflectors here. This is a Newtonian telescope. So the downside, or not the downside, but let's say the concerning point of telescopes is, this is a great design, by the way. The design is pretty clever because it makes making a large telescope cheaper in Newtonians. For beginners, it is a little tricky to point because here's an eyepiece over here, which is an unusual location. With the refracting telescopes, the telescope, there is the light coming or incoming lens, the primary lens. The light comes from this direction, and here is the eyepiece. So we look at and see the object. Pretty easy, like it's similar to binoculars. But in this case, the eyepiece is here. So what you need to do is pointing your telescope, and in the meantime looking from the eyepiece on the side towards the incoming part of the telescope, top of the telescope. So this makes it a little tricky to find the object. In some cases, you would find little additional instruments over here that helps you point the telescope in the first place, but certainly they are tricky. You can find maybe $400 or $500 you can spend, and you can find a good size of that, and they will certainly save money over Cassegrain, but they are not ideal for astrophotography. And the reason is, well, let's come back to this Newtonian example again. So here's your eyepiece, and if you would like to do some astrophotography, you need to take that eyepiece off. And for astrophotography, usually you are using a camera like this. So here you go. This is a similar like a DSLR camera. So this is a heavy camera, and when you connect this camera into this telescope, you have a little problem, and that problem is balance. So the telescope is going to lose its balance, and for astrophotography you need a very stable telescope so your image doesn't shift during the exposure time, and you can take nice pictures. So let's go back to our slides and advance it to what's called Cassegrains. Those are the great masterpiece of telescopes. It is using, the Cassegrain telescope is using a lens in the mirror, lens and mirrors, and the light first comes to a lens which is usually called corrector plate, and the corrector plate's purpose is making some of the corrections that is resulted by the mirror. So because by the nature of light, when light comes to a mirror, it diverts to the focal point, but in the meantime there are some of the impurities that happens to light due to just the physics nature, and those are like a chromatic aberration, the color separation, and things like that. So those are corrected by a lens, and that lens is very high quality, specially manufactured, fantastic lens. So there is a secondary mirror behind the lens, and finally image is diverted to the back of the telescope. So you can use a Cassegrain telescope pretty much like a refracting telescope, because the eyepiece is on the back side. You can just point like you point your binocular, which is great. But the Cassegrains are expensive. And they also come with computerized controls, with sounds very good at the first point. But the problem is those computerized controls are very easy to use, but they require a precise aligning the telescope, the initial alignment. That initial alignment is done every time you take your telescope out to field and set it up. Every time you turn on your telescope, you need alignment. So that alignment is not really easy, and just my experience, the computerized controls tends to go off accuracy in short time, and in most of the time when the telescope is under warranty, they just lose their accuracy. Yeah, there are like a lot of sensors in the telescope that they require reset and trained, and some of the sensors fail, and even some of the motors just lose their accurate traction capabilities. So those are the problems. So my rule of thumb when buying a Cassegrain telescope is I would like to spend most of the money for optics and the least amount of money for electronics. So if you can find a telescope that is giving you a bigger optics but the diminished electronic controls, that's your good direction to go. I would never go into the other direction, spending more money into electronics and invest in a small telescope. Again, for telescopes, the most powerful thing is the most important parameter is the size of the telescope. Get the biggest affordable telescope for your budget. So we will come to another fact, and that is choosing the mount for your telescope. Most telescopes, and especially if they are coming as kits, will be delivered with what we call ALT-AZ or altitude azimuth mount. So that is very similar to a camera mount, which lets you tip over the telescope in high and low direction and left and right direction. So if you know where is your object, it is very easy to point with that. And even some of them will have some computer control, so you can have like a controller on the hand. You can slew your telescope in the direction you want it. But if you are wanting to do astrophotography, or if you are willing to hook up a camera to your telescope, you will quickly find out that this type of mount is not going to be sufficient enough for you. Plus, most of the alt-azimuth mounts, if you are not paying for a good price for it, they are not stable. They are usually made out of lightweight aluminum for portability, and also they are pretty thin, so even a little wind or little wind can just knock off your telescope, or just somebody can just accidentally touch it and knock it off. So those are the typical accidents you would expect. So you need to get a good guard for your telescope if you are using especially lightweight alt-azimuth mounts. But if you are wanting to invest in a better mount, you either buy a little bit heavier duty mount, and especially if you are going to do astrophotography, you want equatorial mount for your telescope. The equatorial mount is not easy to use as much as alt-azimuth mounts, because in case of equatorial mount, your telescope base is tipped over and aligned with the equator. So in this case, your telescope is sitting tipped over on the mount, and when you need to take the control and point your telescope, the motion of the telescopes will be looking very complicated. And it will be very difficult to mount, the point your telescope if you are a beginner. And also in the picture, on the pole, you see some metal discs, and those discs are weights. So depending on how much weight you attach your telescope, for example, your DSLR camera, you will need to shift those weights and even maybe like add or remove some of the weights, and you need to balance the telescope. But once you perfectly balance your telescope, then you are good to go. And if you are doing astrophotography, you will need a camera like this, and you won't need the lens. You will just take the lens off. Those professional cameras come with the feature that you can take the lens off. So that lens will have an adapter over here, and that adapter will go to your telescope. So you remove your eyepiece from your telescope, lens from your camera, and join the two. Your telescope here becomes the lens of your camera. So this is how it works for astrophotography. All right, so besides that, when you are buying a telescope and when you are budgeting a telescope, one of the things most forgotten is the accessories. So you need a good eyepiece kit for your telescope, because probably in the box it will be shipped with 1 or 2 different eyepieces, and not every eyepiece is the same. For example, I'm holding one over here, and each eyepiece has a different size of lens in it. So they are written over here, and this one, it says 9.7 millimeter eyepiece. And on the second one over here, I am looking at 12.4 millimeter eyepiece. So that's the focal length of the lens they used in this little. And what does it mean? It means when you are looking at an object, you need to choose the right eyepiece to get the details of the object. If you use a wrong eyepiece, your object may be either too small, so you cannot see the details, or your object may be too big in the telescope that it is just giving you a fuzzy, nonsense image. So you need to have different sets of eyepieces. So when you point your telescope to the moon, from moon to Jupiter, Jupiter to Ring Nebula, you change the eyepieces. And there is a little useful information on estimating the eyepiece you need. So that's a very simple equation. So magnification equals focal length of the telescope divided by the focal length of the eyepiece. So if you do this division equation, so you end up with a number, and that number will be the magnification. Most of the time it is expressed in the units of x, which means times. For example, your telescope, most of the time it is written on the front lens. Your telescope has a constant static focal length of 1000 millimeters. And if you put an eyepiece on it and it is 25 millimeters, you divide 1000 to 25 and it is giving you 40. So 40, it means your in your telescope, the actual object is 40 times enlarged in your telescope, in your eye. So it is pretty much like the zoom on the cameras. and well, you can put the smallest possible eyepiece and get the great image on your telescope, maybe, but there is actually always a limit, and the maximum magnification is usually you need to multiply your telescope's diameter by 60. This is also an important fact or important number when you are choosing your telescope, because if you are looking for let's say 10 inches telescope in diameter, so you multiply by 60, and this is the number. This is like 600 is the maximum magnification you can expect from your telescope. But 600 times is actually plenty. So here is the telescopes. At least I wanted to give some information for the very beginners on the market. And if you are having any questions, just post your questions in the comments chat, and even after the stream or in the following days, we can try to go ahead and answer the question. And I'm hoping you are liking these live streams. Please give us some live stream ideas, what to talk about, and we will go ahead and consider those. And I hope to see you with another live stream next week. Bye-bye.